Afternoon. Today I'm going to talk about exception handling. It's about how to design robust software. I'm a little nervous. I just realized that I don't always practice my English. But when I do it at a conference. Okay, my name is Iho. Here is my blog and Twitter account. You can get my slides URL from my tweet now, right now. Currently, I work for AlphaCamp. It's a professional school for startup. I teach Ruby on Rails bootcamp there. I have been using Ruby on Rails since 2006. At that time, Rails version is 1.1.6. Anyone older than me? Please raise your hand. Cool. We are exceptional. Okay, here is today's agenda. I will talk about why we should care about exceptional handling first. Then we will quickly learn how we do exceptional handler in Ruby programming language. Then we will look at some caveat and guideline. Finally, we will check out some failure handler strategy. Before entering my talk, I want to thank these two great books. First book is a Chinese book by Dr. Chang. He majors exception handling area professionally. Although his example is Java code, but I still learn a lot of concept from his book. Second book is Exceptional Ruby by FD. I learned many Ruby tricks from this book. Besides his book, he also have two talks at the Ruby conference. I highly recommend you to read these two books if you want to learn more after my talks. Okay, let's get started. Why we should care exception handling. Ask yourself, is feature complete equal to production ready? I think we all know it's not true. Production environment is volatile and the shit happens. Like remote server can go down, data can be incorrect, requests can time out, API code may return error, system may be out of memory. Does all test pass means production ready? It's not true either. It just means software is correct based on spec. Doesn't mean software is robust for production. The reason is that we all focus on heavy normal path. We assume that every method code succeeds, data is correct, and the resources are always available. But there is dark side, the abnormal heavy path that we often ignore. One reason we ignore the abnormal path and sacrifice software quality is that we want to meet our product deadline and budget. After all, abnormal path is a non-functional requirement. It's a quality attribute that our manager or our customer doesn't see it clearly. Another reason I think is that we often emphasize high-level abstract architecture. We learn design pattern, refactoring, TDD that all bring us our code more portable, reuse, and reduce our development cost. But one important lesson I learned from my production experiments is that development cost is not equal to operational cost. Here is my favorite quote from Release It book. Michael said, "Don't avoid one-time development expense at the cost of recurring operational expense. So if your design decision made during development will greatly affect your quality of life after release." I have to confess that I easily made decisions based on optimizing development cost, not operational cost before. And I was miserable and suffered. Our customer get angry and the company lost money, so I decided to change my mind. This is why I start to look at failure handling and give this talk. So if your project KPI is to reducing development cost and deadline, then hope you can have some new perspective from my talk. Okay, now let's get started to learn what is exception in Ruby. Steve explained it at the Code Complete book. He said that write exception is just like alien. I don't know what to do about this. I sure hope somebody else know how to handle it. David explained more straightforward at the well-grounded Ruby's book. He said, writing an exception means stopping normal execution of a program and either dealing with the program that has been encountered or exiting the program completely. So most modern languages have exception handling, like Java, C#, PHP, Python, and of course, including Ruby. Well, except Golang, this is another story. So this is the basic exception handling syntax in Ruby. I think most of you already know it. The rise method will disrupt the flow and jump to the rescue part. One thing you probably don't know is that the fail method is also the same as rise method. There is an interesting coding convention that Chang almost used fail method. He said that he only used rise method when he wants to rewrite exception. So if you check out rec source code, you can see the style. He always used fail method. Very interesting and subtle difference. Back to our rise method, let's take a closer look. This is the method structure, and it can accept 3 arguments actually. If you omit all arguments, then it's equivalent to runtime error. If you give it a string, then it's equivalent to runtime error with a string parameter. If you give it an exception class and string, it's equivalent to new the exception class and passing the string parameter. The third argument is a backtrace. It's just an array of string. The default is caller, which returns the current code stack. Rise method also set up a special global variable to keep the current active exception. It will be reset to nil after the exception is rescued. Let's take a look at the rescue method. Rescue is where we handle error. Rescue keyword is followed by exceptional class, then a hash bracket and the variable name that which the matching exception will be assigned. Rescue method supports multiple class or module. It also supports staking multiple rescue and other methods. If you omit exception class, default it will rescue standard error. It doesn't include other exceptions like no memory error, load error, syntax error. Here is the Ruby exceptional hierarchy. Why not capture the base hierarchy by default? The exception outside the standard error hierarchy typically represent conditions that can reasonably be handled by a general catch-all rescue clause. For instance, the syntax error represents that programmer typo. So Ruby requires you to explicit when rescue this and certain other types of exception. Here is one infamous mistake that many programmers try to rescue exception class. This will make it rescue all exception, including your typo. So in most cases, this is bad for debug. You can also omit the exception class. The default is standard error too. Okay, rescue also supports star separated. For example, Rails have a suppress method. It will suppress exception you specify. In this case, it will ignore IO error and the system call error. And here is the real source code. You can see it use star after rescue keyword. Let's trick about rescue is triple equal sign. It like case statement, except it requires class or module. For instance, we can customize errors with message method that only rescue exception with socket message in this example. This is a customized method. It create a temporary module with a triple equal sign method that using regular expression. In fact, we can make it more general. We can pass the arbitrary block prediction, the errors matching method passing a block to check if it should rescue or not. And here is the method implementation. So, after all, what's the rescue purpose after all? Bird said at the object-oriented software construction book, he said, bring the object back to a stable state, and to either retry the operation or terminate with failure. Next syntax is ensure. Ensure part will always be executed, whether an exception is raised or not. They are useful for cleaning up resource. Next is retry keyword. Ruby is one of the few languages that offer a retry feature. Retry gives us the ability to deal with an exception by restarting len from the last begin block. The most thing about retry is that you should define a giving up condition. Otherwise, the retry will become an infinite try loop. And one of the most simple solution is just a counter. In this example, we defined a counter 3. After 3 times try, it will give up. Else keyword is the opposite of rescue, where the rescue clause is only hint where an exception is raised. Else is only hint when no exception is raised. Let's quick recap what we learned. We learned 5 Ruby syntax about exception handling. They are raise, rescue, ensure, retry, and else. Okay. Next, let's check out some caveat and guideline. About exception handle, the first important question is this situation truly unexpected? Should we use exception or not? The answer is it depends. In the pragmatic programming book, Dave and Andy ask us, will this code still run if I remove all the exception handlers? For example, imagine that we are going to open a file. If the file should be there, then using exception to make sure it's good. But if you have no idea where the file should be exist or not, then it's not an exceptional situation if you cannot find it. Here is another classic example that user input error. We can actually expect the user will make a mistake. We can predict it will happen during normal operation. After all, our user is either fool or evil. Take a concrete Rails example. Since we can expect invalid input, so we should not be handled by exceptions because exception should only be used for unexpected situation. So rather than using exception, we should use normal control flow, normal if else control flow. This will make our code more readable. Exception should only used for unexpected situation. Another classic example is record not found. If you can expect that record can be not found, then you should not use exception for not found situation. One good way to deal with record not found problem is using null object. So rather writing exception when record not found, you can just return a null object. Like this example, we just use null example. We can design a null user object. This will make our code more simple. Okay, here is another example about exception abuse. It's from the refactoring book. You can write in an exception on a condition. The caller could have checked it first. This exception is unnecessary because you can just check it. Martin in refactoring book said that exception should not act as substitute for conditional test. Here the test is more like just check. Spare handler means you provide alternative implementation inside rescue part. This is actually a bad smile. You just make rescue part more complex. We can use the same null object example above. In fact, the null object is just an alternative solution where we call not found. So in this example, exception handling is totally unnecessary. So we can just check it as normal implementation without exception handling. The second big issue about the exception handling is rising during rise. In this code example, the original exception error A is thrown away by error B. We lost the error A information. It's just the error B will override error A. So this is a real problem that if you are not intended to do this, it will make debug harder because we cannot trace original error A because it is override by error B. I am not saying we should not rise during rise. I'm not saying we should not rise during rise always, because sometimes we want to do it. The main purpose is we may want to convert the low-level exception to higher-level exception. It can reduce the implementation dependency and easier to understand for the high-level client. So we maybe want to convert it. So how we fix this? The solution is we swap it to keep original exception. In this example, we rise error B during exception error A, and we define our exception class called myError. Here is myError implementation. We keep original exception here. In fact, Rails use the technique a lot too, like exception wrapper and action controller error and action view template error. They all use the technique to keep original exception. Next issue is similar but worse. It's possible to write exception during ensure part. Not only it will override original errors, but it will also leave its cleanup unperformed. Remember that we know this ensure session mission is to clean up resources. So if it writes exception during ensure part, then it's possible that there are resource linking and it also hard to debug. So please avoid write exception during ensure. Try to make ensure part very simple. Let's take a more concrete example. If file 1 close write error, then file 2 will not close. This causes resource leaking. So try to confine your ensure close to safe and simple operations. Combined above two issues, I give you a challenge here. Suppose we have two resources, R1 and R2, and we run it, and there is ensure part which will close these two resources. And here is the resource implementation will make it fail. Basically, I want to make R2 run successfully. R1 run will write exception. But then R2 close will write exception fail. It failed. Then we can deduce that R1 will not close steadily. So here is the output result. We not only lost the original R1 exception, but we also failed to close R2. How we fix this? The basic idea is to implement a wrapping class to try to stack all exceptions. I left the challenge to you. Next issue, next guideline is I think all of you have experienced that exception is one of the most common source of surprise and frustration with third-party library, because you cannot show what kind of exception may be raised during I call this library. In Java, they try to solve this issue by checked exception and unchecked exception, but it seems not very successful. So unfortunately, it seems no perfect way to solve this issue. What we can do is provide clear documentation, or you can consider no-rise library API. No-rise library API means it either return error code or provide fallback callback. We will check this later. Every library codebase should provide layer error exception namespace. This provides client code something to match on when calling into the library. So client code can choose rescue parent class or children class easily. Here is action controller errors from Rails. Here is his architecture hierarchy. Another simple way we can make our exception more smart by adding more information. In this example, we add a code attribute into our customized error class. Last advice is that we should keep our exceptional class readable and isolated. One single failure handling session leads to clear Ruby code. We can refactor this nested exception handling by extracting method. This nested exception handling, we can extract it. It will become like this. We can omit the begin keyword too. Quite simple and easy to read. Recap what we learned. We learn use exception when you need. Swap exception when rewriting. Avoid rewriting during ensure. Exception is your method interface tool. Classify your exception. Readable exceptional code. Okay, let's see some failure handling strategy. First, there's a concept we need to learn. How we call a method exception handling is safe or not. Exception safety definition comes from C++ standard library. If you never notice your method is exception safe or not, and your methods are not guaranteed mostly, then no wonder your code will crash because you don't know. The weak guarantee is means no leaking. The strong guarantee is commit or rollback. The no-through guarantee is no exception will be raised. Another great perspective is what kind of errors we can handle. We can divide them into two kinds, operational and programmer errors. Operational errors represent runtime problems experienced by correctly written programs. These are not bugs in our program. For example, failed to connect to server, timeout, out of memory. Programmer errors are bugs in our program. These are things that will always be fixed by changing the code, like typo. So we have many ways to handle operational errors. We may restore clean up resource, handle it, propagate, retry, just crash, or log it. But we cannot handle programming error, actually. There is nothing you can do. By definition, the code that's supposed to do something was broken, so you cannot fix the problem with more code. The third concept you should know is robust levels. There are four robust levels which can be our non-functional requirement. Level 0 is undefined, which means you do nothing. Everything is unknown or incorrect when something goes wrong. Level 1 is error reporting, or we call it failing fast. All unhandled exception will be caught and reported. Here is an anti-pattern that rescue error but does not report or propagate. It hides the problem and makes debug harder. Level 2 is state recovery, or we call it weakly tolerant. Your system state will be correct after error. We can achieve this by backward recovery and cleaning up resource. Basically, it means restore original status. We already talked about cleaning up. Let's emphasize backward recovery. Here is another concrete example from the programming Ruby book. It fetches a web page and save it as a file. The critical part in the rescue is that it will do backward recovery. That is delete the file if there is an exception. Level 3 is behavior recovery, or we call it strongly tolerant. Your service will be still available. To achieve this, you have to implement retry and or design alternative solution. Retry primary implementation may work for your some temporary errors like network problem. So in network problem, retry your primary solution may work. But more often, you need to implement the alternative solution for possible operational errors. In this morning, zero downtime payment platform talks, Tien just give a great talk about how they design a failure-tolerant system. What we can learn from these 4 robust levels, we can define our system robust level from the project beginning. We know level 0 is bad, so it's better we require every method is level 1. For critical operation like storage or database operations, we can make sure it should be level 2. Finally, for very critical feature like payment or our customer requires, we can achieve level 3. But please note, level 3 means you will double your development cost at least, because we must implement 2 solutions for the critical feature. The development cost will be double. Strictly, okay, next we check out some strategy. Strictly, timeout is not about handling exception. It's an exception you should raise when you have external code. It can help your system more robust. Usually, our HTTP library already implements some timeouts, but keep in mind that you should have it. For example, if you implement your RPC code by NQP, like using RabbitMQ, then you should have to implement. You need to implement your timeout yourself. Be sure you have timeout. We mentioned retry with a simple counter. Here's another elegant trick about retry: circuit breaker. The basic idea is wrapping a protected function code in a circuit breaker object with monitor for failure. Once the failure reaches a certain threshold, the circuit breaker trips, and all further calls to the circuit breaker return with an error. More details implementation, you can check out Martin's Fellows blog. It's a more elegant design for retry. Bulkheads is a strategy that keep a failure in one part of your system from destroying everything. Basically, it just stops the exceptional propagating. It can help your software more robust, especially for distributed system. Reporting exception to some central location is common sense now. Besides building your own central log server, you can also use just email or any third-party service like Airbreak. Okay, next strategy is exception collection. This is a very useful strategy when you bulk processing data. If you have thousands of data want to process, running test, mini test, or provision assistant, then in this situation, fail first is not good for this situation, because we just want to get a report at the end telling you what part succeeded and what part failed. So if you have thousands of data, you don't want to every exception rise, then stop. You want to get a final report to see it. Caller supplied fallback strategy is a useful trick when you design your library API and the library itself doesn't have enough information to decide how to handle exception. Then the client code can inject a failure policy into the process. In fact, the Ruby standard API uses this trick too. For example, hash and arrays fetch and detect method. What's happened when key does not exist? We can inject a block to return default value. In the practice of programming book, Brian said, in most cases, the caller should determine how to handle an error, not the coding. So you can delegate the decision to the caller in some way. Here is a general implementation. We passed a failure policy block into it. This strategy is saying you should rescue all exceptions at the outermost code stack, so end user will see a nice termination. I think Rails already did a great job here. It provides detailed backtrace at development mode, and it provides error page to end user at production mode. Okay. Next issue is about error code. Error code is a traditional way to deal with errors. In most cases, especially from the object-oriented perspective, is anti-pattern because it meets the normal code and the exception handling code. And more importantly, programmer can easily ignore error code. For example, if the first line prepare something fails and it returns an error code, and the programmer can easily ignore that, then the second line trigger something action will still perform. In fact, in refactoring book, there is even a refactor called replace error code with exception. But there is also a counter view too. It's within the very popular programming language is Golang. Golang doesn't have an exception. In its FAQ, it said they believe error code is better. I also found another guy, one of the exception opponents, also point out the shortcoming of exception that every piece of code can rise as exception. So any suggestion when to use error code instead of exception? One answer I found at State Overflow is, I think it's relevant. He recommends that use error code for lower level code which you must know the behavior of in every possible situation. Otherwise, we have to know every exception that we can write by every line in the method to know what it will do. Okay. Sometimes you really want the kind of go-to feature. Then Ruby provides through catch syntax, so we can distinguish it's not the exception handling. This example comes from Sinatra because I cannot find Ruby real source code use it. Okay, let's recap what we learned. We learned how to decide a method is exception safe or not. We learned there are operational errors and programmer errors. We learn robust levels, and we can improve our exception handling incrementally. We also learn we should use timeout for external code, and learn some strategy like retry with circuit breaker, bulkheads, failure reporting, exception collection, caller supplied failure fallback strategy, and avoid unexpected termination. We also learn when to use error code and through catch flow. That's all I want to share with you today. And thank you for your listening.